A demo MCP server proves the idea. Production proves the system. In this topic, we'll move from works locally to something secure, observable, resilient, and governable, using risk to decide what to harden first. So far, you've built the core MCP picture: how clients, servers, tools, resources, and prompts interact, where servers fit in application architectures, and how lifecycle, capability negotiation, and runtime behavior work. The minimal server proved the protocol path. Now the focus shifts to production readiness: safety, reliability, observability, operations, and governance. Getting an MCP server working locally proves one thing: the tool can be called. That matters, but it is only the starting point. Demos often trade control for speed. Credentials may be simple, logging may be thin, and failures may be handled informally. Production raises the standard. The server may touch sensitive context, trigger real external actions, and influence AI-driven decisions. So the question becomes, should this tool be called, by whom, under what limits, with what recovery plan, and with what audit trail? Prototype MCP servers often optimize for speed, not safety. That is acceptable in a demo, but those same shortcuts become liabilities once real users, data, or systems are involved. Start every production review with 4 questions. Who is allowed to call this server? What credentials does it use? And are they narrowly scoped? Are the tools described clearly enough for the model to choose them safely? And if something changes state, can you see who triggered it, what happened, and how to recover? If any answer is weak, the server is not production ready yet. An MCP server deserves the same discipline as any production integration because it is not passive plumbing. It gives an AI client actions it can choose at runtime: create a ticket, send an email, update a record, trigger a workflow, or read a sensitive resource. Tool names, descriptions, permissions, credentials, rate limits, and audit logs all shape what the agent may do. A small ambiguity can become a large behavioral change downstream. Treat the server as the control boundary between probabilistic decisions and real business systems. Production readiness is not a single checkbox. A server can pass functional tests and still be risky to operate. Think about readiness across 4 dimensions. Security controls who can do what, protects secrets, and limits damage. Correctness and safety make tool behavior predictable, validated, bounded, and safe to retry. Resilience and observability keep the system understandable under stress with timeouts, rate limits, logs, metrics, traces, and audit events. Operations and governance define ownership, release practices, version changes, and incident response. Production means these dimensions are strong enough together. Security readiness starts with one rule: access is never assumed. Every request to an MCP server needs an identity attached to it, whether it comes from a user, service, workspace, tenant, or application. That identity drives authorization. The server should decide which tools, resources, and actions are allowed based on role, scope, policy, and business rules. Avoid shared, all-powerful credentials, because one mistake can expose everything. Prefer scope tokens, delegated access, or tightly limited service accounts. Most importantly, treat every tool as an externally callable capability. Validate inputs, enforce policy, and block unauthorized paths before execution reaches downstream systems. In production, a tool definition is a contract, not just a convenience label. A vague tool like update record leaves the model guessing: which record, what fields, and what consequences. A strong contract names the exact job, defines boundaries, and warns about side effects. The schema helps block bad calls by requiring fields, restricting values, and setting format or size limits. For risky writes, add dry runs, confirmations, idempotency keys, or human approval. Return structured outcomes so the client can distinguish success, partial completion, validation failure, and policy denial. Resilience means assuming every dependency will eventually misbehave. An MCP server should never wait forever on an API, database, or model call, so set explicit timeouts. Retries can help, but only when the operation is safe to repeat and the failure is likely temporary. Rate limits, queues, and concurrency controls prevent one busy client from overwhelming downstream systems. Circuit breakers stop repeated calls to a failing service. When something does fail, Return errors clients can act on: timeout, validation failure, policy denial, or downstream unavailable, without leaking internal details. After an MCP server reaches production, it failed is not enough. You need evidence. Logs tell the story of each request: the request ID, tool invoked, caller context, policy decision, and sanitized error details. Metrics show health over time, including latency, error rates, tool volume, denials, and dependency performance. Traces connect one MCP request to downstream services and external APIs. Audit logs answer the accountability question: who did what, to which resource, and was it allowed? Together, these signals make debugging faster, incidents clearer, and compliance defensible. A production MCP server is not just deployed, it is owned. Name the team responsible for the server, the tools it exposes, the credentials it uses, and the systems it depends on. Then define what healthy means: uptime targets, latency goals, support hours, and response expectations. Incidents should not depend on heroics. Create runbooks for common failures, dependency outages, secret rotation, and rollback. Make escalation explicit across platform, application, security, and business owners, so the right people engage quickly when something breaks. Production MCP servers need disciplined promotion, not ad hoc copying from a laptop. Keep local, development, staging, and production separate, with different credentials, datasets, and access rules. Make deployments repeatable through infrastructure as code and CI/CD pipelines. Each step should act as a gate: run tests, scan secrets, validate schemas, check required configuration, and fail fast on unsafe defaults. Before production, staging should prove integration behavior. Then release gradually with canaries, feature flags, or controlled windows, and confirm rollback is ready before widening traffic. Once clients depend on an MCP server, every tool name, input schema, response shape, and resource identifier becomes a contract. The safest changes are additive: new optional fields, clearer response fields, or a new tool version instead of renaming or changing meaning in place. When something must go away, deprecate it deliberately. Announce the timeline, measure actual usage, identify affected clients, and provide a migration path. The goal is simple: let the server evolve without surprising existing integrations or turning a routine upgrade into an outage. Risk-based hardening means you do not treat every MCP server as equally urgent. Start with 4 questions. What data can it reach? What actions can its tools take? Who can use it? And how critical is the workflow it supports? A read-only documentation server for one developer may need basic controls first. A tool that writes to production systems or exposes customer records needs stronger authentication, tighter authorization, monitoring, and approval gates immediately. This keeps security effort aligned with real blast radius, so teams reduce the highest risk before polishing lower-risk integrations. A demo MCP server proves the idea. Production proves control: authenticated access, least privilege authorization, clear tool contracts, safe writes, audit trails, resilience, and ownership. The goal is not maximum process. It is risk-based readiness for business-critical systems. Next, we'll go deeper into secure access, starting with threat modeling and practical authentication patterns.